been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for geometry, section 10.4, using inscribed angles and polygons in circles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So let me show you what this looks like. So here is an example of an inscribed angle. And so I'm going to put a point out here and call that A. This will be B, and this will be C. So again, B is the vertex, and notice that that is on the circle, and the sides of the angle are chords, or contain chords, right? So this goes outside the circle, but this part right here is a chord on the circle. And what you notice here is that we've now created this arc AC. Arc AC is created by the inscribed angle. The inscribed angle is definitely different than a central angle. Just real quickly, let me remind you what a central angle is. A central angle is when the vertex is in the center of the circle. Okay, so that's how these are different. So an intercepted arc is like what I just talked about, the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So arc AC is the intercepted arc. So I'll go ahead and redraw it down here. So here's my inscribed angle. This is B, this is A, and this is C. And so again, the intercepted arc is arc AC. The next thing we're going to learn is that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Again, using the same example with the same letters, what this means is that the measure of angle ABC is equal to 1/2 the measure of arc AC. Okay, so this angle, the measure of this angle is 1/2 the measure of this arc. Now, remember, if we have a central angle that creates an arc, those are equal. But with an inscribed angle, it's 1/2 of the arc that it creates, the intercepted arc. The next theorem says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if I have this angle here that creates that arc, and I have this angle here, notice that they intersect in the same point. They should. My drawing's a little bit off. So we'll call this B, A, C, and we'll call this D. So because both of these intercept at arc BC, we can conclude that the measure of angle BAC is equal to the measure of angle BDC. An inscribed polygon is a polygon whose vertices lie on the circle. Remember polygons we studied? A triangle is a polygon, quadrilateral, hexagon, all of those. So you can see in this example I did a quadrilateral, and this is inscribed because the vertices are on the circle. So let me give you an example of not inscribed. So that's not inscribed because this vertex is outside the circle. Another quick example of not inscribed would be something like this. Okay, that's not inscribed because this vertex is not on the circle. An inscribed right triangle would look something like this. And what we know about inscribed right triangles is a couple things. If it is a right triangle and it's inscribed, which means that the vertices are on the circle, then we know that the hypotenuse is the diameter. And we would also know that if we had a circle and we had the diameter drawn, so we'll call this circle P, this is the diameter, we know that, and we have an inscribed triangle, then, again, if we know that AB is the diameter, then we can conclude that this is a right angle because it is a triangle that's inscribed. The diameter is the hypotenuse, and across from the hypotenuse is going to be the right angle. So that works both ways. The hypotenuse is the diameter, and if we have the diameter as a side of a triangle inscribed, then the triangle is a right triangle. Always across from the hypotenuse is the right angle. Couple things you need to know about inscribed quadrilaterals is that if a quadrilateral is inscribed, then its opposite angles are supplementary. So this means that the measure of angle B plus the measure of angle D equals 180, and the measure of angle A plus the measure of angle C equals 180. None of those have to be congruent, but the opposite angles have to be supplementary if it is inscribed in a circle, if a quadrilateral is inscribed. So you're going to need to use that property in order to solve problems.
I've been waiting way too long.